Hello, Algebra 2. Let's get started with Unit 4, Day 5. I'm about to do example B for you here. 5 over square root 2. Now, what we're going to be doing is we're going to be doing what is known as rationalizing the denominator. We do not want square roots in our denominator. So in order to fix this example, we're just going to multiply the top and bottom of our fraction by root 2. It's pretty simple. Whatever square root's in the denominator, just multiply the numerator and denominator by that exact same square root. And here's why. Well, 5 times root 2 is just 5 root 2 over square root of 2 times square root of 2 is square root of 4. And the square root of 4 is 2. You would then want to check and see, can these numbers reduce? They can't. That is your final answer. Okay, now let's do 8 over root 3. Since we have root 3 in our denominator here, we're going to multiply our fraction, top and bottom, by root 3. 8 times root 3 is 8 root 3 over root 3 times root 3 is the square root of 9. And the square root of 9 is 3. We will then check, can these numbers simplify? 8 over 3? No, they cannot. So this is your final answer. Now, from this point on, anytime I multiply a root by itself, I'm not going to do this step. I'm just going to move straight to the simplified version. Hopefully you have figured out by now that any root multiplied by itself, it just eliminates the need for the root. So root 2 times root 2 times root 2 is 2, and root 3 times root 3 is 3. Okay, now we're going to do example C. Now I know that what I have written down is not quite example C, but just go with me for a second. If it was simply the square root of 6 over the square root of 8, that would simplify to 3 over 4. I said square root of 6 over square root of, I'm sorry, I meant if it was 6 over 8, it would reduce to 3 over 4. Okay, now, the problem is actually square root of 6 over square root of 8. But we're going to simplify much like we did here, except we just have square roots that are involved in our problem here. Now we have the square root of 3 over the square root of 4. And before you start multiplying the top and bottom of this fraction by the square root of 4, this is where knowing a perfect squares come in handy. The square root of 4 is 2. So we didn't even need to do any multiplying for that problem. All right, example D, 6 root 12 over 7 root 42. I'm gonna simplify these roots. Those are some pretty big numbers. I don't want to be multiplying by root 42. Now, 12 and 42 are both divisible by 6. All right, now we want to eliminate this root in the bottom of our fraction here. So we're going to multiply the top and bottom by root 7. 6 root 2 times root 7 is 6 root 14 over 7. I'm going to write that 7 down here. And now remember, root 7 times root 7 just eliminates the need for the root. And now we can simplify just a little bit further. Our numerator is going to stay the same. 6 root 14 over 7 times 7 is 49. And now you have your final answer. Example E, we have the square root of 27 over 8. Now you need to get used to writing your fractions that are inside a square root like this. That's really what this looks like. Square root of 27 over the square root of 8. Now we've been simplifying roots for a while, so I'm going to go ahead and simplify this very quickly. The square root of 27 is the exact same thing as 3 root 3, and the square root of 8 is the exact same thing as 2 root 2. If you don't know how I did that, please go back and revisit those days where we were simplifying square roots, or just see me during class after class, and I'll give you another lesson on how to simplify roots. Now let's get rid of this root 2 in the bottom by multiplying our fraction top and bottom by root 2. 3 root 3 times root 2 is 3 root 6 over, let me carry this 2 right here over there. Root 2 times root 2 is just 2. And now we know what our final answer is going to be. 3 root 6 over 4. Check to see if you can simplify, but you can't. That's your final answer. Okay, looks like on your notes, next we have guided practice 1 through 4. No, thanks. I'll let you do that stuff on Delta Math. Let's now move on to the very bottom of our notes. All right, on the bottom of page 1 of our notes, we have 2 examples of x squared minus 49 equals 0 because there's 2 different ways that you can go about solving this. This one here, we're going to solve this one by factoring. This is a difference of perfect squares. We're going to fill in these 2 spaces by taking the square root of the very first term here, and the square root of x squared is x. We're now going to fill in these 2 spaces by taking the square root of 49, and that would give us 7. Then we're going to take our factors and set them both equal to 0. And then solve. Here we have to add 7 to both sides. X equals 7. Here we'd have to subtract 7 from both sides. X equals negative 7. Okay, this you've already been taught. Now we're going to use the square root method to solve this one. The goal is ultimately to get x by itself. So we want to, I don't know why I just did that. We want to add 49 to both sides. We're going to add 49 to both sides. Now x is almost by itself, but it currently has a square attached to it. In order to eliminate the square, we're now going to take the square root of both sides. X equals, now the square root of 49 is 7, but we are solving using the square root method, meaning we should have 2 answers. So anytime you take the square root of a number and you're solving using the square root method, put a plus or minus in front of the result. See, it makes sense. One of our answers is positive 7, and the other answer is negative 7. There's the square root method. Move on to side 2. Example G, 5x squared minus 40 equals 0. This scenario here, we could start by adding 40 to both sides. And the goal is to try and get x all by itself. Well, we have to get rid of that 5 next. Now we can take the square root of both sides. I just took the square root. So we want to put plus or minus, sorry about that. We want to put plus or minus in front of our simplified version of the square root of 8. And the square root of 8 reduces to root 2. So these are our final answers. Example H. We're going to start this one off by dividing away the 18. Divide both sides by 18. Now 24 over 18, that will reduce to 4 over 3. Now we can get x by itself by taking the square root of both sides. And since over here we're dealing with a fraction, let's separate the numerator and denominator by taking the square root of both of those numbers individually. Now, we just took the square root of a number, so let me put plus or minus. The square root of 4 is 2. And now we're going to rationalize the denominator by multiplying the top and bottom by root 3. And now we have an idea of what our final answer is going to look like. 2 times root 3 over root 3 times root 3. Check to see if these numbers will simplify, but they won't. Example I. If we're using the square root method, the goal is to get x by itself. So let's subtract 40 from both sides first. Now let's divide both sides by 6. And now we're going to square root both sides of the equation. I just took the square root, so let me write plus or minus. Now, the square root of -80, that's going to reduce. Let's see what it's going to reduce to. There's a pair left over. So the square root of -80 reduces to 4i root 5. I, because we took the square root of a negative number. Don't forget that. Example J. The goal is to get x by itself, but we cannot get into those parentheses until we've moved everything that's outside of the parentheses away from x, starting with that 3. Let's divide away the 3. Well, divided by 3 is 4. Okay, now we can get rid of the exponent. We're going to take the square root of both sides. Now, when you square root a square, it eliminates the square and also the need for parentheses here. Okay, the square root of 4 is 2, but remember, we just took the square roots of that. So put plus or minus in front of our result. Now we're going to add 2 to both sides. And here's what we're left with. We're left with 2 plus or minus 2. What that means is you need to do a little bit more math. We have to do 2 plus 2 and 2 minus 2 in order to get our final answers. So one of our answers is 4, and the other one is 0. Okay, here, if we're solving using the square root method, we want to get x by itself. X is currently inside parentheses, and we cannot get in those parentheses until we've moved everything outside of the parentheses away. So let's start by adding 5 first. Now let's divide both sides of our equation by 2. And now we can square root both sides. All right, over here, square root of 15 will not reduce. And now we can rationalize our denominator. Multiply the top and bottom by root 2. And we have root 15 times root 2 is root 30 over root 2 times root 2 is just 2. Now the square root of 30 will also not reduce, so we're going to leave it like that. Now, since we took the square root of all of this, put plus or minus in front of that result. And then the last thing that we need to do to get x by itself is we need to subtract 2 from both sides. So x equals this. Yes, it looks weird, but we cannot simplify this anymore. Root 30 is an irrational number. So just leave your answer like this: -2 plus or minus root 30 over 2. From here, the rest is just guided practice, but I would much rather you practice this stuff on Delta Math. So go ahead and get started on that. If you need any help with this stuff, come see me in room 402.